Hello everyone, welcome back to my channel. In today's video, I'll be doing this lab on create and manage cloud resources. So this is a challenge lab and it contains 3 tasks. I'll be explaining each and every task so you can get a complete understanding about this lab. So let's get started with the lab. So you can click on start lab. So here you have to click on open Google Cloud Console and sign in with the username and password. Click on next. Here copy the password. Click on next. So let's go to first task. In task 1, we need to create a project jump host instance. So here they have provided the instance name. So this instance name only you should use and F1 micro machine type. So this instance should be of this machine type and the default image type should be Debian Linux. So let's go to our console and activate Cloud Shell. If you click here, it will open a new window. So let's open this in new window. I will take you to the notepad. So you can refer to this notepad. First, we will set some environment variables. So here we will set the instance name. So that instance name we can get it from here. So this is the one. Here they have provided the instance name as well. Towards your left, where you get the project ID. So here you can find the instance name. So let's copy this instance name and paste here. So port we need to use 8081 and the firewall rule. Let's copy this as well. So set these environment variables. So set this instance name and the zone where you will be creating the instance and the cluster. I will export some environment variables and also the port number and the firewall name. So setting this environment variables makes the process more simpler because we can just call this variable wherever we execute this command. Ensure that whatever instance name you get in your lab, you date it accordingly and even the zone and region. So copy this, go to your Cloud Shell. Here, let's execute this. Okay. Here I got an error, not a valid identifier. As you can see here, I have given a space. So you have to ensure that you don't give any space. So let me take you to the notepad. So here you can see the difference. These two variables after equals, there is no space. So if we give a space here, we'll get that issue. So ensure that you avoid this mistake. Let's copy these two variables, go to Cloud Shell and execute. Now we didn't get that error. So you have to ensure that you set the environment variables correctly. As part of this task, we need to create an instance. So let's go to Notepad and take a look at the command. So for this task 1, create a project jump host instance. So to create a jump host instance, we have to execute this command gcloud compute instances create. When you provide this create, it will create an instance and here we are passing a variable $instance name. So this will check the variable which we have already set and it will pick this value from this environment variable and create this instance by the name nucleus-jump host-335 and ensure that you provide the instance name which you get in your lab. Here we are providing the network name. So this is my VPC network, nucleus-VPC. So if you go to VPC here, VPC network, you can find there are 2 VPC networks here. So I'm using this nucleus-VPC. And for the zone, we will be creating in this US East one. So that zone details, if we go to the task 2 here, since we have to create this cluster in US East 1 zone, we can make use of the same zone to create our instance as well. So I have given the US East 1. So whatever zone you get in your task, use it accordingly. And then here I'm specifying machine type as F1-micro. So we have to create an instance of F1-micro machine type. So that is very important. You use only this machine type. If you use some other machine type, then your task will not be completed. And image family and the image project name, it should be Debian. So let's copy this. Here under Cloud Shell, let's execute this command. So this will create an instance in US East 1 zone with a machine type F1-micro. So now you can see it has created this instance. So if we go back to this page, click on check my progress, this task should be complete. Next, we need to create a Kubernetes service. So here we need to create a cluster in this zone. Then we need to deploy a Docker container HelloApp using this image. Then we need to expose this app on port 8081. Let's go to our notepad. Task 2 here. Task 2, create a Kubernetes service cluster. So there are 3 commands which we need to execute. So the first step we have to do is we need to create a cluster in region US East 1. So here we need to execute gcloud container clusters create. For creating a cluster, you need to run clusters create and provide a name to your cluster. So app cluster is a name which I am giving, and num nodes represents the number of nodes it has to create, and the network I'm using the nucleus -vpc, and the zone I'm picking it from this environment variable which I have set to you. So let's copy this, go to our cloud shell and execute it here. I'm executing each and every command so you can get a complete understanding about this challenge lab. So let's do it one by one instead of executing all the commands at a time. So this will take some time for the cluster to get created. Cluster is now created. So here you can find the name of the cluster and the location where it got created, and it has assigned the IP address. So it's IP address, machine type, it has created E2 medium machine type, and the number of nodes, it has created 1. So if you don't specify any machine type, by default it will create E2 medium. So on the status you can and the status of this cluster is running. So the cluster creation is complete now. Next we need to use a Docker container hello-app, and we have to use this image to create this container. First we need to connect to the cluster, then we need to deploy this container. First we need to ensure that we have the necessary credentials and access to the Kubernetes cluster. In order to do that, we have to execute this command gcloud container clusters get credentials and the cluster name, and the zone we need to specify. So let's copy this and go to our cloud shell. Here let me execute this command. So now you can see there is a kubeconfig entry got generated for this app cluster. Now let's move ahead with the task. Now we need to create a deployment. So here I have given the deployment name as hello-app-server. So any name you can give, whatever name you want to give, you can give that name. You have to use this specific image only. So that I have mentioned here, -image is equal to this one. So let's copy this and go to our cloud shell. I will clear this screen. So I will paste it here. Now this got created, the deployment got created. Next, expose the app on app port number. So if we go back here, so they have given this port number, we have to expose this. So this specific command creates a service to expose the deployment named hello-app-server, and here -type is equal to load balancer. So this specifies the type of service to be created as a load balancer. So this will allow the external access to the deployment. So when we execute this command, Kubernetes will create a load balancer service that exposes this deployment hello-app-server which we have created just some time back on this specific port. This load balancer will provide a publicly accessible IP address and route traffic to the pods which is associated with the deployment. So let's copy this and execute it here. A service got created and it is exposed. So as you can see, service/hello-app-server is exposed. Click on check my progress and this should be complete now. Now the assessment is complete. Next we need to set up an HTTP load balancer. So we will be serving the site via Nginx web servers. We also have to ensure that the environment is fault tolerant. So for that, we need to create an HTTP load balancer with a managed instance group of 2 Nginx web servers. So 2 Nginx web servers will be creating, and we need to use the following code to configure the web servers. So this code we will be using there. So this given code snippet is a bash script that is used to create a file by the name startup.sh, and it will populate it with a series of commands. Apt-get update, this command will update the package list for app. So this is a package management system in Debian-based Linux distribution. Next, apt-get install -y nginx. So this command will install the nginx web server by using the apt-get. So here the -y flag automatically confirms the installation without prompting for user confirmation. Next service nginx start. So this command will start the nginx service. Next we are giving this sed -i command. So this command will use the sed utility to replace the text nginx in the index.nginx-debian.html file, which is located at /var/www/html with the string Google Cloud Platform, followed by the host name of the machine. So your $host name will insert the value of the host name environment variable. So overall, this script will update the package list, installs the Nginx, starts the Nginx service, and then modifies the default Nginx page to display a customized image which indicates the Google Cloud Platform and the host name of the machine. So that's a brief about this code snippet. So we have to copy this, go to our Cloud Shell, execute it here, execute it here into. So now it has created a startup.sh. So let's head back to our notepad. So I have copied this to my notepad here. So first we need to create an instance template. So to create an instance template, you need to run this following command: gcloud compute instance -templates create. Then we provide the instance template name here. So you can provide any name as per your wish. And then we are passing this metadata from file startup-script. So this is a startup.sh script that we are passing here. Then the network, VPC network we are specifying here. And the machine type, this will have a machine type of G1 small, and the region, we are referring to the specific region. So let's copy this command. Let's run this command again, gcloud compute instance -templates. Now it will create the instance template. Now this is complete. Next we need to create a target pool. So here we will execute gcloud compute target -pools create. Since it contains nginx web servers, we are creating it with this name, nginx-pool, and the region, we're specifying the region where it has to be created. So copy this command and go to the Cloud Shell and execute it here. Now it has created the nginx pool in the US-East 1 region. Now let's go back to our notepad. Next, we need to create a managed instance group. So here I am passing gcloud compute instance -groups. Since we are creating an instance group, we have to pass this. Since we are creating a managed instance group, we have to provide here as a manage, then followed by the create and the managed instance group name. So this is the name of the instance group. So you can provide whatever group name you want and the instance name. So this will have a minimum 2 instances that we are specifying here, and the template name. So instance template name we are passing here. So this is the template which I have created in the first step. So ensure that you pass the instance template name, whatever you have created, that name should match here. So let's copy this and let's execute it here. So now it has created an managed instance group by this name, and the base instance name it has set it here as appso. Next we need to create a firewall rule name as this. So the firewall rule name should be this to allow traffic. So whatever name they have mentioned here, you have to ensure that you create a firewall rule with the specific name. So in my lab, I have this name, so I'm using this specific name. So here I will execute gcloud compute firewall -rules create followed by the firewall name. So this one I have set it as an environment variable. That is why I'm passing it as $firewall_name. So it will fetch the value from this environment variable. And then -allow TCP. I'm allowing the traffic on port 80, and the protocol will be TCP. And -network, I'm specifying the VPC network here. So let's copy this command, execute it here. So as you can see, it's creating a firewall rule. Now as you can see, it has created the firewall with this name and network nucleus -VPC, and the direction of the traffic is ingress and the priority is 1000, and it allows the traffic on port 80, and the protocol is TCP. So let's move ahead with the lab. So next we need to create a health check. So to do that, let's execute this command gcloud compute HTTP -health checks followed by create and the health check name. So you can provide any name as per your preference. So let's copy this command, go back to our Cloud Shell and execute it here. Now the health check has been created. Next we will execute this command. So this command is used to configure the ports for a managed instance group. So by running this command, we will be configuring a name port for the specified managed instance group. Here the port HTTP is associated with the port 80, so this will allow the traffic on port 80 to be directed to the instances in the group. This specific configuration will enable load balancing and routing of traffic to the appropriate instances, which is based on the named port configuration. So we are performing this specific step now. Create a backend service and attach the managed instance group with name port HTTP. So let's go with this command. Let's go to our Cloud Shell and execute it here. So now it has updated this. Next, we need to create a backend service and attach the managed instance group with a name port. So by executing this command, we are creating a backend service by the name apps-backend. This will use the HTTP protocol and we are associating with the HTTP health check, and this backend service will act as a target for load balancing and routing traffic to the instances, which is based on the health check results. So here hyphen protocol we are setting is as HTTP and and HTTP health checks. So here we are giving the health check name. So let's copy this command and go to our Cloud Shell and execute it here. So this will create a backend service. So now it has created the backend service by this name, and it has set the HTTP as a protocol. We are adding the instance group AppServe and group as a backend for the backend service, which is named AppServe-backend. So this will allow the backend service to distribute incoming traffic to the instances in the specified instance group, which is based on the configured load balancing. Let's copy this command and execute it here. So now it has updated this. Let's move ahead. Next, we need to create a URL map and target the HTTP proxy to route request to your URL map. We need to execute this command. Copy this and execute it here. Now it has created this. This is the name and the default service. Now next, let's copy this command and execute it here. Now you can see this got added. Let's go to Notepad. Next, we need to create a forwarding rule. So let's copy this command. Go to Cloud Shell, execute it here. Now this also got created. Let's copy this command and execute it here. Now this is also created. So let's go back and let's list this forwarding rules list by executing this command. Copy this. So we can list the forwarding rules list by executing this command. Gcloud compute forwarding rules list. So here you can see all the forwarding rules which we just added just now. So all the rule details you can find here. So now we have completed the lab. Let's go back to this main page and click on check my progress. So now this should be complete. So I'll be attaching this notepad in my GitHub repository. So you can follow these steps to complete this lab. If you found my video helpful, please like and subscribe to my channel and stay up to date with the latest content on my channel. Thank you all for watching. See you in the next video.